All right, here we'll be going through problem 10.6 as an example covering non-inertial reference frames. So in problem 10.6, it asks, a bucket of water is set spinning about its symmetry axis. Determine the shape of the water in the bucket. So if you look on the top left, we have a bucket of water and it's not rotating, and the water in itself is not rotating either. Then in the top right, we have the bucket starts to rotate, but it's so early that the water itself doesn't rotate yet. But eventually, if we keep spinning this bucket for long enough, then the water, due to friction along the contact with the bucket, will start to also speed up, and it'll also spin with the same rate as the bucket. And then eventually, if we stop spinning the bucket, the water will continue to spin for some time. So what we're going to focus on for this problem is the bucket is spinning at the same speed as the water. So we have the bucket spinning and the water is spinning. And that spinning with a constant angular velocity will cause this surface to start to change shape. Okay. So let's write down all of our forces. So we have that the effective force is going to be whatever the real force is minus mass times, and we have capital R double dot, and we'll have a little f there, plus omega dot cross R, plus omega cross R, plus 2 omega cross VR. So what do these different terms mean? Okay, so we have the effective force in this rotating frame is going to be whatever these real forces are minus R double dot, and that is going to be due to the accelerating frame. But we're just assuming that this bucket is staying stationary. It's just that it's rotating. So this bucket itself isn't accelerating or going away from us or anything like that. So that is going to be 0. And if we're looking at this bottom left case, where the bucket and the water are spinning at the same speed, then everything's in constant motion, and so we don't have an accelerating of the bucket or a deceleration of the bucket, so we're going to assume that this term is also 0. And then the Coriolis force, 2 omega cross VR, that is when we have something in the bucket is going to be moving. So say if we had like a little rubber ducky or something like that in this thing, and if it were like swimming along or something like that, then it would have some Coriolis velocity or Coriolis force due to its velocity. But just looking at this bucket of water, there's nothing really moving. So the only fictitious force that we have to deal with is centrifugal force. Okay. Now, in this frame, while we're in this scenario here at this bottom left case, what we have is nothing's really going to be changing, right? This bucket of water is going to have this new shape, but it's going to be just stationary. So that means that if nothing is changing, then there's going to be nothing accelerating. And if there's nothing accelerating, that means that this effective force is 0. And so that's going to be F minus M omega cross R. Okay? Now, what are the actual real forces going on here? Well, this bucket of water, we're assuming that it's standing on, it's on Earth, so we're going to have some gravitational force here. And then we're looking at the surface of this water. And so because this is some interface between a liquid and air, there's going to be some surface tension. Okay? So that surface tension will be pointing away. This is the same way that we treated that problem before, that we had a cylinder that was sitting, in water, and when we're discussing simple harmonic motion, we moved this cylinder a little bit, and then we saw that this object buoys up and down with simple harmonic motion. It was the same kind of way that we treated that problem. Okay, so what are the real forces? So what are the real forces Well, that's going to be gravity, so mg is due to gravity. And we're going to have S, which is due to surface tension. Okay? So, let's zoom in on this interface. What we have is this distorted water surface, this distorted water surface interface. And this is going to have some surface tension here. And this little point here is going to have some mass, and it's going to have gravity pulling down. Okay? Now this surface tension will be making some angle theta to gravity, and that will also be angle theta. Okay? Now we need this to have some coordinate system, so let's use an x and y coordinate system, and we'll use x from the center, since we'll be dealing with centrifugal force, and so let's use this as our x, and that will be our y. So these are the two real forces, gravity and surface tension, but then we also have this fictitious, well, let's draw this to the right size. We'll also have centrifugal force. So this is negative m omega cross r. Okay? So from before, we said the effective forces are actually going to be 0 because nothing's actually accelerating. So we have 0 equals s plus mg minus m omega cross r. So let's look at these components, because we're going to have some in s and some in x, or some in y and some in x. So in x, we have negative s sine theta plus m omega squared x, and that's going to be equal to 0. And in y, we have s cos theta minus mg, and that's going to be equal to 0. So what we have is s sine theta is equal to m omega squared x, and we're going to have s cos theta is equal to mg. So we're just going to divide these two, and what we get, the s's cancel, the m's cancel, and we get tan theta equals omega squared x over g. Okay? But we have to be careful here about what tan theta actually is. So if you think about what tan theta is you look at what this angle is and you say, oh, well, that's going to be cosine over sine, but that seems kind of strange. So if we actually look at it a bit more carefully, what we have also is here. This is also theta, okay? So that, from this theta here, we have tan theta is going to be our dy by dx. So then what we get is tan theta equals dy by dx equals omega squared x over g, or what we have is y. Well, we have dy is equal to omega squared over g x dx. So of course we integrate, And what we get is y is equal to omega squared over 2g x squared plus some constant. So that means that this is parabolic.